Now what we're going to do is to look at a couple of examples to see how these things can be used. So in the Attribute Examples project, let's take a look first of all at example 1 in the servlets. We've got a model, control and view. Take a look at the controller first of all. Well, we're not expecting any problems here, so we haven't got any try-catch blocks or anything like that. But the basic process is this. We're going to dispatch the request to the model component, and then we're going to dispatch the request to the view component. So something really, really simple, because what we want to focus on is the mechanism of communication between the model and the view. So let's go and look at the model first of all. In the model, what we're getting from the request are these two parameter values, and then a little bit of validation. If there was no first name parameter, then we are going to set our variable first name to be just the empty string. Likewise for last name. And then we're going to create a new variable called full name that is the combination of first name followed by a space followed by last name. So this is a very trivial, almost nonsensical example, but it's going to illustrate the communication mechanism between model and view. And the way that happens is this. When the model has produced the data that the view needs, it's going to set it as an attribute. And so the variable full name becomes the second parameter in the setAttribute method. We have decided that the name that we want this attribute to be called is full name. We can use any name that we want, any string that we want, but of course it should be meaningful to help us, the programmer, and the other programmers who might come along to maintain this code at some point in the future, to help us all to get an understanding of what this attribute should be. So that's the first part of the mechanism. The model has generated some data. Now, of course, this could be that the model has communicated with a database, extracted some data, and put that data into a JavaBean, and then the JavaBean will be set as the attribute. That's going to be one of the other examples we look at later on. But for now, instead of using a JavaBean, we've simply used a string and put that string as an attribute into the request scope. And it's important that we remember which scope it's gone into, because since each scope is isolated from all the other scopes, if we put it into one scope, then we're going to have to go back to the same scope to retrieve it. So having activated the model, and the model has set up the attribute, control comes back to the controller, and you'll notice that the controller does absolutely nothing with this particular attribute. And so it simply activates the view. And what the view component does, in this statement, is to call from the same scope request the getAttribute method and passes in as the parameter the same attribute name that was used to set the attribute. Now remember, getAttribute, if we take a quick look at the drop-down list by hitting Control space and then narrow the list down a little bit, the getAttribute method returns a reference of type object. Now we know that this attribute is of type string, and therefore we typecast the reference from a reference of type object to a reference of type string, which then allows us to store that reference in this variable of type string, and then we can use that as an ordinary string object. So that's how we have the model set an attribute in the request scope and then retrieve it in the view from the request scope. And the other examples that are in this particular project do exactly the same thing, except that example 2 uses the session scope and example 3 uses the application scope. Let's take a look at a slightly more involved example. Let's close down all of those windows. And now we're going to take a look at this example, the beans example. We've got a number of servlets here. The controller. We've got 3 model components: get the table, delete a row, insert a row. Remember when we talked about MVC in the previous lecture, we said that each model component should limit itself to one act of functionality. Insert is one act of functionality, delete is another, get is a third. And by separating these concerns, okay, we've multiplied the number of servlets that we've got in the system, but on the other hand, we've now got something that is very flexible, because we could have several requests that as we process those requests, we might need to get the department table. But if we've built that into some other kind of functionality, then we're going to have to start duplicating code, which is not what we want. So we separate it into its own little model component so that we can call it as often as we need. And there are two view components, one where there's no problems and the other where there is problems, and we've got to report the error. For the gdmAtStaffs component, to generate data, it's going to have to communicate with the database. The view will need to display that data, and so we're going to use the JavaBeans as the communication mechanism. So gdmAtStaffs will generate one or more of these objects, and the view will retrieve them from the scope that gdmAtStaffs set it into, and then will display the data in some way or another. The way the view displays it is view dependent. So here we have yet another example of separation of concerns. It doesn't matter whether this is an HTML view, an XML view, some other kind of view. It really doesn't matter. The generation of the data and the storage of that data as an attribute does not change depending upon the view. It's only the view that changes. And so the view will then display it in a way that is appropriate for its client. We could also have two different views. Let's say both are HTML views. For the same piece of data, we could traverse that data and in one view expose all the data, and yet in a different view with exactly the same data we might expose a summary. So one of the very good reasons for separating view from model is so that we've got this total control and total flexibility about generation of data and display of data. Let's take a look at some of the detail here. Start off in the HTML here. We've got a form. It's going to send in a request to Beans example, and it's passing in two parameters, one called uname and the other called pword. These are values that are provided by the user and are going to become the username and password for connecting to the database. So when that is submitted, the controller will try to get hold of a command parameter, but back here there was no parameter called command. Therefore, command is going to be null. Therefore, that line will generate a false for the Boolean expression, and so the if is not done. And therefore what the controller does is immediately call getDepTable. So let's take a look at getDepTable. The username and password are retrieved from the request, and they are then used along with the URL for the database to set up a connection to the database. And we saw how that worked in a previous lecture. This URL is valid if you're wanting to use the student Oracle database on campus. Otherwise, you're going to have to change that, as we discussed in a previous lecture, to make use of, let's say, the JavaDB database that ships with NetBeans. Because we're going to be retrieving rows from a table, we're going to need an array list to store the data from those rows. And that array list is going to become the attribute that this model is going to set up for the view to consume. For us to do that, we're going to need to take a look at this JavaBeans. The dept.java class tells us about it. We've got three properties: dept, no, dname, and lock. If you're familiar with Oracle at all, then you'll recognize those column names from the default dept table that comes with just about every installation of Oracle. Now, because this is going to be classed as a JavaBeans, we need to have a default constructor. It needs to be a public class, and it should implement the java.io.serializable interface. And it doesn't in this example. Therefore, this is not a JavaBeans, even though we might have put it into a package called Beans, and that is really a bit of a problem. So what we'll need to do is to put in here implements java.io.serializable, and that now becomes a bean because we've satisfied all three of the minimum requirements. Because this is a default constructor where we will just set these 3 string variables to the empty string, then we have set and get methods for each one of those. And that's the bean. So nothing terribly complicated. So back here in the getDep table, Servlet, we have now got an array list that will hold dept objects. We're calling it list, and it's initialized to just be a new list. Then we set up the connection. Here's the SQL string, the SQL command that we want. Select star from dept. We're going to create a statement, and because this is a select statement, we will execute query. And that is going to return a result set object. While this result set object returns true when next is called, in other words, while we still have rows from the result set to process, then for each row we will create a new dept object and then populate each of the properties within that object by using whatever rs.getString returns. Set dept no using the data in the dept no column from the result set, and so on for the dname and lock. Having populated the bean with all the data from that result set row, we then add the bean to the array list. So the first row is encapsulated in that bean and is then added to the list. Next time around, if there's a second row, that will then be encapsulated in a new object and added to the list. Third row in a third object, added to the list, and so on. Eventually, there will be no further rows to process, and so the while loop terminates, and the only thing left to do is to take that array list object, which now contains references to all these dept objects containing the data from the database, and set it as an attribute called dept table on the request scope. Then, of course, we need to close the result set, close the statement, and that's the end of the model component. So what we've just seen is a mechanism for extracting from a database the data related to a particular request, put it into some bean objects, which are then encapsulated within a single array list object, and then put that array list object as the attribute, the one attribute in the scope. We could have many more than just one attribute on a scope. There's no limit, but here we're just using a single array list object that holds all the row objects. So let's come back now to the controller. The next thing it does is to activate the view. So let's take a look at view. This is a servlet, and what it does on line 21 is to get from the request scope the attribute called dept table, which of course is the name that was given when the model set the attribute. Then, because get attribute returns the reference to this array list as a reference of type object, then we are going to have to do the typecast. The array list dept is the type for this object. We're doing the typecast so that we can now store it in the local variable here called list. Now, of course, things can go wrong, and therefore we really ought to test to see if list is equal to null, because if it is, that's a problem. We were expecting the list to exist, even if it was an empty list. You can have a list object with no row data in there because the table was empty. That's legitimate. But to have no list object at all, that's a problem. And therefore we would throw a new servlet exception with the message to indicate what the problem is. But if list is not null, then the if doesn't happen, and so we can then iterate through the array list. And in this example, we're simply just setting up an iterator that is going to iterate through the list, of course. So here's the view. This is what we're doing. Set up the header information for the message back to the web browser, and we're outputting how many rows were affected. That's not relevant really for a selection. We'll see more of that later on in this example. And then we're going to iterate, and for each time we iterate, we're outputting an HTML row to go in that HTML table. Let's take a quick look now at what happens when this button, which is part of the rest of the view, there are two buttons that are going to be displayed on the web browser, one for insert and one for delete. The one for insert is going to cause the controller, because there will be a command parameter. Let me show you how that gets there. You see how the name of this button is called command in both cases, but it's got a different value. The user's only going to click on one of these buttons and that will submit. So whichever button has been clicked, we'll be able then to determine by looking at the command value whether it's an insert or a delete, and therefore know which of the other model components to activate. I'll show you the insert and you can look at the delete in your own time. So the insert will get the request parameter, uname and p-word for connecting to the database. In this case, it's going to insert hard-coded values. So it's going to always insert the same thing. And then do the update. And then on the request scope, it's going to set an attribute called rows affected to say how many rows were inserted. Having done that, the controller is going to activate the getDept table model again to extract all the data from the table and then activate the view. And so the view will now be able, as well as getting the list, it will now find that this attribute, rows affected, exists. And therefore it will be able to report how many rows were affected, as well as show the current contents of the database table. And so you get to see there the flexibility of having individual model components with one area of functionality per model component. Okay, so take the time to review this code, download it, see how it works, and if you have any problems, then get in touch and ask your questions.